In this video, we're going to talk about drawing valid conclusions, and we're going to do some simple proofs. In this first question, it says that we're given that angle LOP is a straight angle. Angle LOM is a right angle, as you can see from the little box, which is the symbol for a right angle. And the measure of angle NOP is 30 degrees. I'm going to put that into the diagram. List as many conclusions as you can. Feel free to pause the video so you can come up with some of your own conclusions, and then you can unpause the video to check your answers. Well, if angle MOL is a right angle, then angle MOP has to be a right angle as well. And the reason for that is because angle LOM and angle MOP are supplementary. In fact, they form a linear pair because they're supplementary and adjacent. So if angle LOM is 90 degrees, then angle MOP also has to be 90 degrees to make 180 degrees. And then, from there, we can figure out that the measure of angle MON needs to be 60 degrees, because 60 degrees plus 30 degrees makes 90 degrees. There are lots of other conclusions we can make as well. We can say that we have line segments, ON, OP, OL. We can say that we have rays in the diagram, but these are the main conclusions that we can draw. So I think we have a good amount, and it's time to move on to the next question. For these diagrams here, we're going to draw as many valid conclusions as we can as well. So feel free to pause the video, take a look at the two diagrams, and draw as many conclusions as you can. You might have put for number 1 that AT is congruent to TM. But in fact, that is not true. And the reason for that is we do not know that T is the midpoint of AM. It never tells us that T is in the middle of AM. Is the midpoint of AM. It doesn't give us congruence marks here and here. So we have no indication that T is actually the midpoint of AM. So we don't know that AM is being split equally in half. In fact, a lot of diagrams are not drawn to scale, and they'll be drawn to look a certain way to make us believe something's true, even though it is not. What we can say, even though we don't know exactly where T is located in relation to A and M, we know it's somewhere in between A and M. So I can write T is between points A and M. We can also put that we have line segment AM. We can also put that there are rays. For example, we have ray TM. We have ray AM. Right? You can write that we have line AM, lots of conclusions that you can draw here, but you cannot say for certainty that T is in the middle of AM. So you do not know that AT is congruent to TM. For number 2, we have a lot of conclusions that we can draw here. We have line CU and line LN. We can even say that the two lines intersect. Let me fix that. And they intersect at point H. And we know when we have intersecting lines that we have vertical angles that are formed. So we know this angle is vertical to this, and this angle is vertical to this angle. So I can write angle CHL and angle NHU are vertical angles. And since they're vertical angles, I can also state that they're congruent to each other, or that their measurements are equal to each other. I could say the same exact thing for the other pair of vertical angles as well. There's other conclusions we can draw also, like that angle CHN and angle NHU are supplementary angles. Any two angles next to each other here are supplementary because they add to form a straight angle 180 degrees. So plenty of other conclusions, but the vertical angles is definitely a big one there. Same thing, pause the video and see what conclusions you can draw. For the first one, we're given that E is the midpoint of BD. So this time on our line segment, we do know for certain that E is the midpoint of BD. So we do know it's split into 2 equal parts. So I can say that BE is congruent to ED, and my reason is a midpoint splits a line segment into 2 congruent parts. For number 2, I can say angle 6 and angle 5 are supplementary. I can also say angle 6 and angle 5 form a linear pair, because not only are they supplementary, but they're also adjacent. They're touching each other. Here, we have a construction of a perpendicular bisector. The symbol over here is the symbol for perpendicular, if you don't remember. So please take a moment, pause the video, and try to draw 3 valid conclusions based on the construction. Well, one conclusion I can draw is that AE is congruent to EB. Sorry, AC is congruent to CB. And the reason for that is because the midpoint splits the line segment into 2 congruent parts. I can also say that we have right angles. And if I call this point point D, I can say, for example, angle AED is a right angle. I can say angle DEB is a right angle. I can also say the same thing for these 2 angles here. There are 4 right angles that are formed. Here we're given that AB is congruent to DC, and we have to figure out what conclusion we can come up with. Well, if I take AB and to AB, I add on BC, I end up with this whole segment AC. And if I take DC and to it I add on this whole segment CB, I end up with DB. So I can figure out that AC is congruent to DB based on the given information. Let's talk about why this addition works. In order for us to be able to do this addition, we have to be starting with 2 congruent things, and AB is congruent to DC because that was the given information. And we also have to be adding on 2 congruent things. So we do need to know that BC is congruent to CB, and that wasn't given to us. But if you take a look, BC and CB are the same exact segment. So we're adding the same segment. So BC is congruent to CB because it's the same segment. We have a property that says anything is congruent to itself, and that's called the reflexive property. Once again, the reflexive property states that anything is congruent to itself. And then our addition works, and AB plus BC gives us AC. DC plus CB gives us DB. So we say that we're just replacing the addition with what it actually gives us, and we're just replacing this addition with what it actually gives us. And that is substitution. When you replace something with something else that's equivalent or means the same thing. Let's try another example. Here, we're given that wy is congruent to xz. And what we need to arrive at is we need to prove that wx is congruent to yz. Now this time, I see that we're starting with longer segments, and the segments that we need to prove something about are shorter. So instead of addition, because we don't need to make things bigger this time, we're going to use subtraction because we need to actually make things smaller. So this time, we're going to use subtraction. And I'm actually going to write out the subtraction over here at the bottom before we fill in the 2-column statement reason proof that's provided here. I'm starting with wy. And to wy, if I subtract off this piece right over here, which was xy, I get wx, which is what I wanted to end up with. And on the other side, I'm starting with xz. And if I erase this part, xy, then I end up with just yz. And I'll just show you one more time. So once again, and I'll just erase everything and I'll start from the beginning again. If I start with wy and I subtract off yx, oh, that eraser is not working well right now. Let's try it like this. Let's see if that works better. If I start with wy and I subtract off xy, much better, I'm left with wx. And over here, if I start with xz and I subtract off xy, I'm left with yz, which are the two segments that I want. So we're starting with two congruent things because wy was congruent to xz from the given information. And then we just need to make sure that we're subtracting something that's congruent. And xy is congruent to xy because it is the same segment. xy and xy are the same exact segment. So that's an example of the reflexive property because if it's the same segment, it's congruent to itself. So now I can see exactly what needs to go in the proof. The reflexive property that I need for my subtraction is xy congruent to xy because that's what I'm subtracting from both of the longer segments to get the shorter segments. Then I can actually do my subtraction. So my subtraction is wy minus xy is congruent to xz minus xy. And that is subtraction. From our subtraction, it leaves us over with wx congruent to yz through substitution because wy minus xy is wx and xz minus xy is yz, so we're just replacing the subtraction with what it actually leaves us over with. Last but not least, our given information that wy was congruent to xz. And there we have our proof completely filled in. Let's try it again one more time. We're given angle BAC congruent to angle EAD. So here's angle BAC. And here's angle EAD. So the green is what we're starting with. Let me make that a little bit better. Okay. And I'm going to put what we're proving in red so we could see it. angle BAD, so that's angle BAD, is congruent to angle EAC. So we're starting with the two green angles and we're trying to end up with the two red angles. So we're starting with smaller angles and we're trying to make them larger. So this is going to be addition. And you could even see where the overlap is between the two red angles. The overlap is here. So this is what's going to be added to both of the green angles in order to make the red angles. So let's write this out. I'm going to write my addition over here at the bottom. So I'm starting with angle BAC. And to angle BAC, I'm going to add this yellow angle, CAD. And that is going to give me the whole red angle, BAD. The other green angle that we're starting with is angle EAD. And to that, we're going to add the yellow part as well. You can call it CAD, you can call it DAC. It is the same exact thing. And that's going to give us the red angle, angle EAC. Let's check out our addition. So we need to be starting with two congruent things. And that was given. That angle BAC is congruent to angle EAD. And we just need to make sure that we're adding two congruent things. And angle CAD is congruent to angle CAD because it is the same angle. That yellow angle is being added to both to make the red angles. So we can say that angle CAD is congruent to angle CAD due to the reflexive property. So I'm going to put this all into the proof now. Now we just have to transfer. So we have angle BAC congruent to angle EAD that was given to us. Now we know that the reflexive property that we need is the two yellow angles, which is the same angle that's being added to both of the green angles, angle CAD. So angle CAD is congruent to angle CAD. And now we can put our addition. Angle BAC plus angle CAD is congruent to angle EAD plus angle CAD. Sorry for the mess here, but it's the same addition we had at the bottom. And that leaves us over with the larger red angles that we just made through addition. Angle BAD congruent to angle EAC. A couple of other proof examples. We're given here that angle 3 is congruent to angle 4. And our goal is to prove that angle 1 is congruent to angle 2. Let's think about why this is true. If I put angle, let me use a different color other than yellow. If I put angle 4 and angle 2 together, I get a straight angle, which is 180 degrees. Same thing with angle 1 and angle 3. So I can say that they are supplementary. Angle 1 supplementary to angle 3, angle 4 supplementary to angle 2. Let's for a second give some numbers to angle 3 and angle 4. Let's say that this is 60 degrees and this is 60 degrees, because whatever one is, the other one has to be, because we were given that angle 3 is congruent to angle 4. Well, since angle 1 makes 180 with angle 3, there's no option but for this one to be 120. And since angle 4 and angle 2 make 180 degrees, if angle 4 is 60, angle 2 also has no option but to be 120. So we see here that since angle 1 and angle 3 are supplementary, and since angle 4 and angle 2 are supplementary, and we already know that angle 3 is congruent to angle 4, there's no choice but for angle 1 to be congruent to angle 2, because it has to be whatever number's left over to equal up to 180 with what angle 3 and angle 4 already is. So we have a better way that we can state that in the proof more generally, because we don't actually know what the measurement of angle 3 and angle 4 is, but we know that since they have the same measure, angle 1 and angle 2 have to have the same measure as each other. So let's fill in the proof over here, and we can put that into words. So angle 1 supplementary to angle 3, angle 4 supplementary to angle 2. We know that because angles that form a linear pair are supplementary by definition. And angle 1 and angle 3 do form a linear pair. Angle 4 and angle 2 do form a linear pair. They're supplementary and adjacent. So now we can determine that angle 1 is congruent to angle 2. And we saw before with the numbers why that's true, but now let's put it into words. So we can say angles that are supplementary to congruent angles have to be congruent. So angle 1 and angle 2 were supplementary to congruent angles 3 and 4. So they have no choice but to be congruent to each other. This one uses a very similar idea, and this is our second to last proof that we're going to see in this video. The only difference is this time we're not dealing with supplementary angles. We're actually going to be dealing with angles that are complementary, that make 90-degree angles. So if we take a look at the given information, they tell us that angle ABD and angle CDB are right angles. So I'm going to just put that into the diagram. Always a good idea to mark your diagram. And we're also told that angle 2 is congruent to angle 4. I'm going to put that one actually in a different color so we could see it better. Angle 2 is congruent to angle 4. And our goal is to prove that angle 1 is congruent to angle 3. Well, let's use some numbers like we did with the supplementary angles in the last example. I'm going to give 30 degrees to angle 2, just making up a number. And we know angle 2 and angle 4 are congruent, so then this has to be 30 as well. And since we know that angle ABD is a right angle, I know that angle 1 has no choice but to be 60 degrees to make 90 degrees with angle 2. And since angle 4 is already 30 degrees, and angle CDB altogether is 90 degrees, I know angle 3 has no choice but to be 60 degrees to make 90 degrees. So we see here that angle 1 has to be congruent to angle 3 because it has to be whatever the number is that's needed to make 90 with whatever angle 2 and 4 are, since they're already congruent to each other. So just like we did with the supplementary angles, we're going to put this into words when we write our proof, because we don't actually know what the numerical value of angle 2 and angle 4 is, but we do know that regardless of what the number is, angle 1 and angle 3 have to be congruent because they have to be whatever number is needed to make the 90 degrees with whatever angle 2 and 4 are. So first, let me put the given information into our proof. We have that angle ABD and angle CDB are right angles. And we also have that angle 2 is congruent to angle 4. Now, we know that angle 1 and angle 2 are complementary, and we know angle 4 and angle 3 are complementary as well. And I'll just write how we know that. Angles that add to 90 degrees are complementary. Or you can say angles that together make a right angle are complementary. Any way of wording that is totally fine. And now we can say that angle 1 is congruent to angle 3. And let's word this the same way we worded it with the supplementary angles. Angles that are complementary to congruent angles have to be congruent. So angle 1 and angle 3 were both complementary to congruent angles 2 and 4, so they had no choice but to be congruent to each other. This is our last proof that we're going to see in this video, and this uses some different angle relationships. From our given information, we're told that ray BD bisects angle ABC, so angle ABC is being cut in half, so angle 1 is congruent to angle 2. We're also told that angle 3 and angle 2 are vertical angles, and I know that vertical angles are always congruent, so I'm going to mark that in the diagram. Our goal is to prove that angle 1 is congruent to angle 3. So let's try to figure out why this is true while we fill in the proof. So first I'm going to fill in the given information. So ray BD bisects angle ABC. And from that, we concluded that angle 1 was congruent to angle 2. And that was because an angle bisector splits an angle into two congruent parts. We were also given that angle 3 and angle 2 are vertical angles. That was given to us. And from that, we were able to determine that angle 3 was congruent to angle 2, because vertical angles are always congruent. Whenever we have intersecting lines, they create congruent vertical angles. So now we just have to figure out why the proof statement is true, why angle 1 is congruent to angle 3. Well, let's look at what we proved in 2 and what we proved in 4 a little bit more closely. In 2, we proved that angle 1 was congruent to angle 2. In 4, we proved that angle 3 was congruent to angle 2. So notice how angle 1 and angle 3 are both congruent to angle 2. So let's say that angle 1 was 60 degrees. It's congruent to angle 2, so angle 2 is 60 degrees. And angle 3 is congruent to angle 2, which we know is 60 degrees, so that has to be 60 degrees. So they all have to be congruent to each other. So angle 1 does have to be congruent to angle 3, because angle 1 and angle 3 are both congruent to the same angle 2, so that means they have to be congruent to each other. I'm going to get rid of these numbers since we don't actually have numbers. So once again, since angle 1 and angle 3 are both congruent to the same angle 2, they have no choice but to be congruent to each other. And this is the transitive property. And the transitive property states, if two things are congruent to the same third thing, they have to be congruent to each other. So here, angle 1 and angle 3 are congruent to the same third angle 2, so they have to be congruent to each other. And that's what the transitive property states. So I'm going to put that over here. Angle 1 is congruent to angle 3 due to the transitive property.